Okay, here's our video today, the secant-tangent theorem. And it's a lot easier than it sounds. Doesn't have to be difficult. So you just need to know what a secant line is and what a tangent line is and some algebra. So let's do it. Let's do an example. So let's create a secant line. Let's say we have a line that touches. Remember, secant touches at 2 points. So let's create one over here. We'll have there's 1 point. Let's call it D. And it's cutting through 2 points in the circle, like a chord, and then it's going out, right? So, and let's say it lands here. So we have D, why not call that C, and why not call that B? So we know that B is the external point. It's outside the circle, right? So this is the secant line. And remember, at minimum, it touches 2 points in the circle. Let's make it a little darker. Here's the 2 points, D and C. And for this theorem, the tangent line has to intersect the secant line at point B. So we'll create a line, the secant line, right to point B. So that's the tangent line. Tangents only touch at 1 point on the circle. And we'll call that point A. So we have AB, CD. Now the formula is saying if you take the tangent line, the entire length of the tangent line, let's just say it's 6. So it's going to be 6 squared. So we know that's 36. The entire length of the tangent line squared is going to equal the length of the secant line, the entire length, which is BD, plus the external length of the secant line. So let's just put some numbers. Let's say this is 4, and this we don't know. We'll just say x. So we know that it's going to be 4 times the entire length, and the entire length is, put in parentheses, 4 plus x. That's the entire length, because we don't know what x is. So we have to do some algebra. So let's change the color of the pen. Bring it back to yellow. So we know that 36 has to equal, and distribute now. Just distribute, doing some algebra. It's going to equal 16, because 4 times 4 is 16, plus 4x. And, here's our simple algebra. Just let's subtract the 16 on both sides. Fix that 16. So we now have 20 equals 4x. And of course, we want the x by itself. Divide on both sides. X equals 5. So we know if x is 5, right? So 5 plus 4 is 9, right? We'll bring it up here, right? Here's the arrow. Instead of having x, we have 5. So 9 times 4 is 36. So 36 equals 36. We proved the theorem. Let's do another one. Let's clear this out. Try to clear it out anyway, right? There we go. Clear it all out. And keep that same. Let's just say now, well, let's do another tangent line. Why not? We'll do another one here, right? And we'll do another secant line going right there. Just made it. And, whatever letters we want to use. Maybe we'll use R. Who knows? Maybe make that an S, T, U, whatever. It doesn't matter. Let's say we don't even know what the tangent line is as x. But here we have, let's say that's 12. Should make it a little darker. 12. And here we have 4. Do you think you can do this one? Now here, what's going to happen is you have to remember algebra, right? And quadratics. So we know that the tangent line squared, in this case it's going to be x squared, has to equal the entire length. Here we have 12 plus 4, that's 16. And it has to equal 16 times what? 16 times 4. Right? So what are we going to do here? 16 times 4 is 64. So x squared has to equal 64. And if we square root both sides, x is 8. So that is the secant-tangent theorem. All right.